Hello, welcome to my advanced JavaScript CA1 presentation. My project is FakeFlix, I've called it. This is a NodeJS and Express app with a MongoDB backend. It's designed to copy Netflix as well as I reasonably could. I just had a look through the structure of Netflix and said I'll try and copy it. Obviously it isn't exactly the same, but it's the general structure of it is as similar as I could reasonably get. I realize we're limited for time, so straight off I'm just going to have a look through my README because that has most of the additional features that I want to show off. I'm not going to go through all the basic CRUD. It's there. I just don't think we have time to explain all of it in every case. I have about 4 things that I want to go through in the code itself. We'll have a look at the Insomnia endpoints, test it out. I have a couple of slides explaining a few concepts and this README. So here we go. Additional info API call from TVMaze. Use the more detailed true query param on the show endpoint to get more detail about the show. That's sort of what it says in the tin. You say use more detail true as a query param. And then we're going to make an API call with Axios to TVMaze using the IMDb ID from my dataset. Again, I don't think I mentioned actually, that's about 5,500 listings from Netflix. It's films and movies and shows. So I'm using TVMaze because we have IMDb IDs, so that was handy. Multi-tiered user authentication. Again, I tried to follow the structure of Netflix. I was looking the way people usually have master account, and then you can have different profiles on the account. I have sort of a replica of that. On top of that, I have subscription type. You can be subscribed to shows or movies or both, and you have maturity settings. Somebody could be a child and they have the strictest maturity settings. Somebody could be unrestricted where they can see anything, or they can be somewhere in between. So user permissions object generated from maturity setting, subscription type, and user type. We'll look at that in the code. Preliminary calls are made before each request with no filtering applied. Filters are then validated against the response to let the user know why they can't access a resource. So yeah, in the auth controller, I'm going to make every call once with no filters. See if they can access that resource. If not at all, then I'm going to say, no, sorry, you can't. If it failed because of their maturity settings, I'll pass it through anyway, filter it again and say, look, here's why it failed. Change your maturity settings if you want. User types are admin, user, and child. Each user/child is an admin ID, tying the admin to a child or a user. So they're related, they actually have object IDs and you can populate them. In the same vein, avatars, they're tied to avatars too. And every user has a list of favorites, which again are real object IDs. You can populate those too to fill them all in when you're looking at them. There is also another user type, which is DatabaseAdmin. And I added that because I wanted to be realistic about this if I could. You know, I'm thinking of the user, the admin, and the child as customers, whereas the database admin is a staff member. Customers can't add, edit, or delete movies from the database. That wouldn't make sense. They can only edit themselves or their avatars, whereas the database admin can perform CRUD operations other than read on the titles themselves. Only the above types have been faked with another valid type, database admin. There you go, that is permitted to do all these CRUD operations. User favorites all have a list of favorites tied to object IDs. You can populate them. You can see them on the manage profiles endpoint. Avatars, they all have real avatars tied to another object. Again, you can populate those. Automated seeding. I did this in an effort to save code, but in reality I ended up probably writing the same amount of code as somebody who did a Faker script by hand. I used 2 libraries. One of them was mongoose-schema-jsonschema, which will convert your mongoose schema to a JSON schema, which is like a language for validating your schema. And then we use another library to generate fake data called json-schema-faker. I passed faker.js into this JSF. You don't have to necessarily, but I did to get better data. So I convert from mongoose to JSON schema, then generate data based on that, and I have a lot of custom methods that make it a bit better. We'll have a look at it. npm run seed use, it'll generate 10 avatars, 100 users with object references between admins, users, and children. Every child or user is going to have an admin. Admins don't have admins. Every user, no matter what the type, is going to have an avatar, and they're all going to have a list of favorites. They're all tied to real object IDs. Search key has been added to the database, so I have fuzzy search on some of the endpoints. You can make a mistake, do a typo, it's still going to work. The titles endpoint, single title, and the show endpoint. The second one accepts IMDb IDs as well. I validate them, make sure they're real. In that case, if you pass in an IMDb ID, I'll validate it, say, is this an ID? If so, I search by the ID. If not, we just do a fuzzy search with a string. Sort by, sort direction, and limit query params on all title endpoints excluding ID. I didn't get that working on ones that use aggregate functions where we return an array. You have to pass a pipeline into them, and I got the match working to filter them out properly and search with the fuzzy search, but I couldn't get the sort working. Small bug. Stripe integration, that's the last one. When registering a new user, Stripe customer and charge objects are generated. The correct fee is charged depending on the type of subscription. So if somebody subscribed to, they want movies, we'll only charge them, say, €6 for movies, or €6 for shows only, or they say we want movies and shows, charge them €12. Stripe details are going to be saved to the user object, then put into the database on MongoDB, and then the charge is actually going to go through and appear on my Stripe dashboard. So we have a relationship between the user in MongoDB and the user in Stripe. Last bit there, avatar images hosted on S3 bucket. That's nothing special. I added in image uploading with Multer as well, but the images, just to have a couple of images, are hosted on an S3 bucket for the avatars. You can see some screenshots there, what our payment gateway looks like with Stripe. Nothing amazing, no styling, because we're using an EJS template. That's it. So moving on now to my slides. So here we go. Agenda, we're going to look at Node.js, Express, REST, and authentication. Might have a look at the Mongoose driver as well. I think I have a slide on that. So Node.js, what is Node.js? It's a JavaScript runtime environment written in C++. Google's V8 JavaScript engine is embedded within the Node.js runtime, which allows it to execute JavaScript natively instead of in the browser. Obviously, we don't have access to browser APIs like the DOM. We can't use the window object, but we can use OS APIs. We have access to the file system. We can use HTTP. So that means we can run JavaScript outside the browser. So people use this to make native apps. They use it to make APIs, obviously server-side apps. That's what we've done in our case. And Express, where does Express and Mongoose come in? Node.js itself is fairly bare bones for making APIs. It doesn't have any specific support for web dev tasks, even though it's commonly used for that. That's where Express comes in. It's a Node framework which provides the features simplifying the process and abstracting away some of the boilerplate that we don't want to have to write. It handles HTTP requests, routing, and it responds to requests. You know, it can send back HTML, whatever. It would be much longer. We could do it from scratch in Node, but we'd be reinventing the wheel. So we may as well use Express. And similarly for, let's say, Mongoose sort of is to MongoDB as Express is to Node.js in our case. It's abstracting away the boilerplate for MongoDB queries, writing them by hand because they're sort of tedious. So the Mongoose driver just makes it simpler as a go-between between Express and MongoDB. So we're doing CRUD operations, it's going to make it easier. We don't have to write as much code. What is the RESTful architecture? It's representational state transfer, which just means that we're transferring a representation, like a subset of our data, from the database to the user. That's what that means. The client's going to send the HTTP request to the server. Server's going to respond with the resource based on the endpoint they're going to. It could be HTML, JSON, or a static file like an image, which we have all that in our case. REST API is the most common type of API used in the web. There's SOAP as well. That's an older protocol, I think. Not used as much. Authentication, we'll have a look at this in the code. How do we authenticate in this app? As HTTP is a stateless protocol, that means that you pass a request via HTTP. It's not going to remember what you did. It's not going to, once the request has been processed, everything is gone. So the question is, how do we validate someone and stop them from having to log in every time, validate every time they want to access some resource, authenticate themselves? We use JSON web tokens. So somebody's going to log in, we'll generate a token, and then in practice, if we had a front end, somebody would save that token to the browser for the duration of the session. Say it could expire in 2 days or something like that. But because we don't actually have a front end, we just pass it through whatever request we make. That's it. So moving on to the code. The first thing that I want to have a look through is the seeding. So to start that off, as I said, I used 2 libraries for this. So as an example, I'm going to have a look at the user schema. It's applied to the avatar schema too. The title schema, no, because I didn't generate that. That's just a CSV that I converted to JSON. So you can see here we're using mongoose-schema-JSON-schema rather than just mongoose. And I'm generating my model and my schema from mongoose-schema-JSON-schema. Some of these they have sort of special things about them, like I'm generating my own IDs. We'll come back to why we're doing that. See down here we have faker name.firstname. We can pass that in and faker will just generate that based on the schema, which is really cool. Username here, you can say I'm generating the username based on a first name and a last name with internet.username. I'm doing the same thing here with email. And if we didn't pass these in, by the way, we could take that out and it would still work. JSF itself would say, okay, it's a string, it generates some lorem ipsum, but faker is better, so we extended faker into JSF. Some of these are sort of special. I have custom methods on them. Avatar, you can see we have type as object ID. It refers to an avatar, which is this avatar schema, the model I should say. Faker, this avatar, that's not a faker method, it's a custom method, and we'll have a look at them in a sec. There's those maturity settings I was talking about. Autoplay, we don't worry about that one. Subscription, there's a custom method I'm running on that one. In this case, we're saying that we have to make sure you aren't an admin, because an admin has to have a subscription type, because their sub-users are going to inherit that off the admin. So if you aren't an admin, you don't have to have one because it's going to inherit it anyway. If you are an admin, you need to choose what subscription type you're going for. And you see that as well when you're registering a user, because you have to pay for it in Stripe. My list, there's nothing in here because we're going to generate that ourselves after we faked our data. And then admin, that's the same as the above. We're going to, actually I have a custom method in there just to get the validation to go through, but then I'm going to replace these with custom values afterwards. We'll see that now in a sec. Stripe details, I'll talk about that later as well because there's a bit more to it. So moving on from the schema, sort of the entry point for the fake is here in seed. We have this generate method, which is async. We call that here in generator, which says generate 10 avatars. And then once that's finished, we're going to wait for that and then generate 100 users. So they both, we pass these schemas. I have these objects here with schema and model together just for convenience, so I can pass them in at the same time. We pass them into faker maker. Once faker maker is finished, we're going to say await type.model.create. We're just going to save our stuff to the database, and then that's fine. So what does faker maker do? We'll have a look. Faker maker is going to take in our model schema. We're going to say, okay, drop the collection if it exists. If it doesn't, that's fine. It just won't do anything. Loop through the number of entities that we asked to make, so the quantity. You can see we have if the type is user schema. That's handy the way I passed in the model and the schema at the same time. We can do stuff like that. I have these custom functions, hash a password, just hashing the user's passwords to make it realistic. Get an ID. I'm doing that so sub-users can refer to that ID. You know, we couldn't have generated these users, let the admins get pushed to the database, and then made the relation, because we wouldn't have known what the ID is going to be beforehand. That's why I'm generating my own ones so we can refer to them. A couple of options there, we'll skip over those. Get avatar, that's another custom method. We'll have a look at that in a sec because I have them all in the same place. And then outside the schema, no matter what, whether we're using avatars or users, we're going to run this JSF extend faker. So into JSF, I'm passing faker.js, which I've imported. I spread the faker object and pass in all these other methods that I want to use. We're going to say down here, JSON schema equals schema.json schema, which is generating our JSON schema from the mongoose schema, converting it out so JSF can use it, because that can't accept mongoose schema. That's the reason that I'm using that converter first. We're saying await resolve. That's going to fake our data, actually generate the fake data, push it into the fields in the schema, and push it up into an array. Again, we're going to say if it's users, run assign values, and let's see what's happening in here. Assign values, we're going to separate out the admins and every other type of user. We loop through them. If type is admin, delete the admin field, which got faked. We don't need an admin to have an admin field, so get rid of it. Delete the list, because this is fake data. We don't want it. We're going to have real data now in a sec. Random number between 1 and 12. Get favorites. We're going to get a return value from here. We're going to say how many titles are there in the database. Get a random one, and then push them all into an array and send it back to the user, so we have real references to favorites here. Come back down, we're going to return the admins back up, give them a new mongoose ID, generating one like this, and give them their list. And then we're going to loop through all the other users. We're going to say get a random admin. Delete the users list as well, because it's fake data. We don't want fake data. We're going to get favorites for them too, but we're going to assign them an admin. We're going to take a random admin from the array that we just got there and say this is your admin, so that every sub-user has an admin. We're going to say subscription is admin subscription because it inherits, which I think makes sense because the person who paid for it is going to be the one who chooses how much they're going to pay. We return them both, spread them out into the one array. I mentioned that get avatars method, that's sort of the same as get favorites. It just we count how many are in the document, get a random one back. And finally down there you can see we have this get image, which is just passing a number. We're going to go through a loop and say i+1, say get image number 1 from S3 or whatever it might be. So back in Faker Maker, we return that back into CJS, and then that's fine, all our stuff has been made. Now, moving on from there, the next thing I want to have a look at is authentication. So we'll look at how the JWT works first off. If I go into my controllers, my title controller, and I find my login method. Sorry, not title controller, user controller. Where are we? Login. login. So how this method works, we're going to say user.find1, find the user with the email that made the request. If that user exists, then if the user doesn't exist, we're going to throw an error and say that's not a real user. Otherwise, run jwt.sign. We're going to make a JSON web token, pass it in this payload, which is going to get encoded into this JSON web token. We have an app key that we're going to process to make it unique and say expires in 2 days. So somebody gets one of these tokens, that's good for 2 days. Pass in all good in the message. We're going to pass the token back. And then in server.js, which we haven't looked at yet, we have this app level middleware. And that's going to run no matter what endpoint we're going to go to. It's always going to run. We're going to say, does the request have a header called authorization? If so, split it where there's a space. If the first word is bearer, the second word is going to be our token. Get the token and pass it into JWT verify, and it's going to return back decoded. If we get decoded, we didn't get an error, then pass decoded into the rec.user object and go next. Next just means continue on from this middleware, everything's fine. And then the next time somebody tries to go to a protected route, see the way some of these routes have login required middleware, all we have to do is say if rec.user, if they have their token and all their payload decoded from JWT, then that's fine. They're logged in. They're a valid user. So proceed. That's where we have next as well. So that's proceed from this middleware. Otherwise, it's not valid or you're unauthorized. So that's validation with the JWT or authentication with the JWT. Now I have my own custom sort of middleware, which I mentioned. First one of them I'll go through. Sort of a prerequisite to that is this age ratings. If you see in here, I mentioned that every user, their validation bar their JSON web token is generated based on their maturity settings and their user type. So in here I have all these maturity settings: restricted, which is for children or just somebody who wants to have a restricted type, a middle one, which has a few more but also inherits from restricted, and unrestricted, which inherits from the other two and has the highest levels, you know, mature or R-rated or completely unrated. We're going to have these age ratings objects for convenience. In get filter, we're going to generate a filter for every user. Every time somebody registers, I'm going to give them a filter. So we're going to say get the person's object type and get their maturity settings. We're going to say if the user is a child, we'll automatically apply the highest level of restriction with maturity settings. Otherwise, just take the maturity setting from the user and say, okay, there's the maturity settings. And then what's that going to do for us? We're going to have this object with age certification and this in regex. Let's say this is allowed. It might be shows and movies. This regex matter. You know, if somebody has shows and movies, then I'm saying if the word shows or movies is in response, that's fine. Let them see it. Otherwise, it's shows, make it singular because that's how it is in the database. Or it's movies, make it singular. And then we're going to be able to pass it into our requests. You know, if we're doing find one, we can say find one by filter. Only show the user results that match, say somebody was subscribed to shows, only show them shows. If they're a child, only show them kid-friendly stuff or any variation on that. So with that in mind, we can see some of our middleware. If I go into my routes, my titles route, well, there's a lot of different variations on this, so I'll just take one type, I suppose. For example, checkSubscriptionType. This is a sort of a long function because it handles it in a lot of different ways. The simplest one is probably just shows. If someone requests a type, if they go the type endpoint where you're either looking for all shows or all movies, we use that filter.regex and match it against, say, does it include the type that they're looking for? If it doesn't, say, no, sorry, you're not allowed to see that. You have to upgrade your subscription. Otherwise, go next. That's fine. For any other type, I'll just take, I'll take the shows endpoint as an example because it's a bit different as well. So in here, we're saying we're going to get this temp filter. We're going to say this is a shows endpoint only. So modify that user object, the user filter object, and say they can only get shows. No matter what to subscribe to, say it's just shows. Did the user pass in an IMDb ID? We're going to validate that against this regex to see is it a valid IMDb ID. If it is, we're going to search by IMDb ID. Otherwise, we're going to search by string. You can pass a string or an IMDb ID. If they search by a string, I mentioned we have fuzzy search. We're going to use this aggregate title, pass in the filter, spread the requests, and use this search pipeline. That's aggregate functions need that because they return arrays and you give them a series of steps. That's how my fuzzy search works. So aggregate title, pass in a search pipeline. We can look at that. We generate different search pipelines based on what somebody wants. In this case, we're just going to have search, which is no filtering on it. It's just going to be fuzzy. You can make a mistake, that's fine, but we're not going to filter the results. You have other ones where I'm going to apply a filter. And the reason that I have these different stages is in the auth controller, I want to make an initial request, see what comes back with no filters, say, okay, did this request fail based on the user's account type? Are they subscribed to shows and they try to get movies? If so, they're not allowed to see that at all. Sorry, tell them no, it failed. It failed because you're not allowed to see that. But if it failed and it failed because of their maturity sentence, I'll pass it through anyway and say, okay, there are results, but it failed because of your maturity sentence. And that's because they can change them if they want. You can edit your profile and say, okay, I want to have unrestricted sentence, which I think makes sense. So what we'll do is we'll run our function, our fuzzy search. If somebody passes in a limit, we'll use the limit. If not, we'll just say 5. If we got data back, we run this get authorized results, which returns back 2 variables, authorized results and failing fields. And in there, how does that work? We pass in our data, our filter, and a boolean. And we say, okay, filter our data. And then on each one of these, we're going to run compare fields. In this case, we passed in true for this boolean. We're going to check subscription type. And that means we're going to get our filter and say, okay, does our filter include the resource type that this person requested? Did they ask for movies and they're only subscribed to shows? If so, we're going to filter through the ones that came back false and then get the object value of the one that came back false. So we're going to say, okay, this one failed. This is the reason that your request failed. It failed because of maturity sentence. You know, your request has an R-rated film and you're not allowed to see that. We're going to filter that back. We're going to see which ones fail. The ones that don't fail, that pass that test, are going to be authorized results the user is allowed to see. The ones that fail, we're going to pass them back anyway so that they can see these are the ones that failed. So going back to our auth controller here, we get our authorized results that you're allowed to see and the ones that you aren't allowed to see. We pass them back to where we called it, all the way down here, if I can find it now again. Yeah, we called it there. We get our response. We set it to our global variables up the top because all of these functions are going to use this. So we just have let's at the top of this. And then that's our else for an ID type. This is just our show. If I go all the way down to the bottom, they're all going to use this. I'm going to say, no matter what request type you made, are there failing fields and there are no authorized results? In that case, it failed. We're going to use verify authorization and look through the results. We did that. We're going to say which attributes failed, which ones don't align with the account settings. Did you get a type of movie and you only subscribe to shows and you don't have any authorized results? If so, say, sorry, didn't find anything. If somebody was searching for a title, we say, okay, maybe if you increase your search limit, say get me 100 instead of get 5, you might get something back. And we tell them failing fields, this is the reason that your request failed. Review these attributes of your account. Otherwise, if it was a single ID we were looking for, return one result, which is just response. In this case, we were looking at the aggregate function, which was going to return an array. So we say unfiltered response is authorized results. An unfiltered response, we pass that through next. And we see now what will happen with that unfiltered response. Not get by name, that was the get show method we were looking at, which is where, here it is. So the request now is going to have unfiltered results passed in. We're going to say these are the ones that, you know, there were some values that were allowed through, but let's filter them on this side. Because this time we're going to filter them with maturity sentence instead of just show type. Because we've determined now that there's stuff the user is allowed to see, but it might be the case that they don't want to see them. They're not allowing themselves to see mature programs or whatever it might be. So we say, okay, get our request, which is going to have our unfiltered values. Get our filter and pass it in. Say check failing fields. We're going to filter through this and say compare fields again, except this time we're going to pass in false, that boolean, which means this time we're going to say check the maturity sentence, see if any of these failed. If some of them failed and we get no authorized results back, we're going to say nothing came back because of your maturity sentence. That's the point of this. This could go through again and say, okay, here's all the results. Some of these are 18 plus, the user doesn't want that. Filter them out and show them the rest. Otherwise, if they all fail, you can say, you're allowed to see this, but it failed because of your maturity sentence. Change your account settings if you want to see them, which I think makes sense. Where are we gone? back in our title controller. Yeah, so if failing fields.length, we're going to return them, otherwise return false. So if this comes back with nothing, we say, okay, we're all good, make the request and show them what comes back. So that's one of my authorization types, one of my middlewares. I do have other ones. I have two more, I think. If we went to titles, then I have this other very small one. I mentioned that only a staff member can do CRUD operations other than read on titles. That's where isDatabaseAdmin comes in. We just see, does the user have the special type on their profile? Is DatabaseAdmin true? If so, they can do what they want. Otherwise, only staff members, database administrators, can do CRUD operations. And then on our users, I mentioned that we have, again, there's comments here explaining this stuff in detail. I realize I'm probably going over time. I have this adminRequired. That means, say for example, if an admin tries to edit a user, we're going to say, okay, get the ID they passed in, see if that's a user who is one of their sub-users. And if they're trying to edit somebody who belongs to them, that's fine, they can edit them. If they want to delete them, that's fine too. If an admin deletes themselves, it'll cascade, and then they'll delete all the sub-users on their account. But if somebody tries to delete and we say, is this an admin, and they aren't, and they're passing in an ID trying to delete somebody else, we say, no, you can't do that. No matter whether it's somebody in your family group or not, a sub-user can't delete somebody else, only an admin can do that. In the same vein, if a sub-user wants to edit themselves, that's fine. If they want to delete themselves, that's fine. But somebody else, only an admin can do that. So we'll have a look at this. So it's simple enough. We're just checking if ID and admin. We have a couple of different cases. This could have been a switch case, really. If ID and admin has passed an ID, so they're going to delete somebody else. Otherwise, if no admin and ID, it's not an admin, somebody else is trying to delete somebody else, they can't do that. A sub-user is trying to delete somebody else. Otherwise, if admin and no ID, the admin is just trying to do something to their own account, that's fine. Go next. So that's it for my middleware, my authorization middleware. The last thing I want to have a look at is Stripe. If I go into my user controller to the register function, we'll see how this works. So register. We're going to save our new user. If this is a duplicate email, throw an error, that's not allowed. Error code 11,000. Otherwise, we're going to say, okay, we say that we've got our user. Now, res.render home. That's an EJS template. We're going to say render the home route, pass in all this data. We're going to go to our EJS template now. That's like it's like HTML. You can put JavaScript variables in it. We have this PK test. That's a public Stripe key. We're going to pass in some information about our user. See here, I mentioned that we have price, subscriptions, new users. We're going to get the subscription type from the user and use this object to say, here's the right price for what the person is trying to buy. And the charge is going to go through to the to Stripe then. So we call this home. We actually have a view here for that. Here's home. And then in home, we're going to say method is post. This is sort of like stuff from second year PHP. We have the action is going to be charge. It's going to run a charge endpoint, which I haven't looked at yet. That endpoint is only for Stripe. We have this Stripe script, which is going to generate a Stripe form and pass it in Stripe public key. And in here I have these hidden fields. The reason for that is that I got these from a post request. So we got our post data in here. We say, here's our hidden data. And when we call charge, we can pass that through. And we're going to be able to access this stuff in our function that actually handles the charge itself. So this charge method, this is in our server. If we can find it, there it is. So here's /charge. It's going to run charge, passing in request and response. If it's successful, we're going to send back some data. Registration successful, thank you. Let's have a look at charge. So we have rect.body.stripe token. We got that from our post params in home.ejs. A token gets passed through from here, and we need that to make a genuine looking Stripe charge. If you don't pass a token, then it's going to say that's not valid. Yeah, so we get them. We're going to say create customer. And now we're going to find a user with the email that we just passed in. So we're going to say find that person, and then stripe.customers.create with that person's details. So here's the data that comes back. Give them that email. We pass the token in here as well because we need that to create a Stripe customer. And give them the name. And then once that's done, we get a response from Stripe if it's valid. And then we're going to wait to say find one and update. And then we're going to pass in Stripe details and spread them. That's why earlier on I showed you the schema and it was just left empty. I didn't do anything with it. That's because I'm not passing that in until now. So we're gonna find the user who's trying to buy something, trying to register. We're gonna say find the user that just got made in the register function, and now we're gonna pass our Stripe data in here. We return that back down here, get our Stripe details, await Stripe charges create, pass in our price. We got that from our query params. Currency is euro, and Bob's your uncle. It's done. Now I'm sure I probably talked for far too long there. I'm gonna have to cut some of that out. Moving on, I seeded the database again, so I'm going to have to actually register a user. That's good because I can show off the Stripe. I'll just say Jake Black, and I'll make myself an admin with unrestricted movies and shows just so we can see whatever we want. So send gives us our gateway. So we're going to get movies and shows is our email. This is the Stripe testing card. You can only use this for Stripe. 4242 424 pay. We're going to get our response back. Success. So now we have our account, Jake.Black, and if I can see behind my screen there. So there's our JSON web token. So now we can go to whatever endpoint we want and search for stuff. Sort, and we'll take out the sort. That's done. And let's give it a limit of, what's that, all 20. There we go. This is again, I'm subscribed to movies and shows here. This is just give us back everything. A lot of movies we're getting, but there should be shows here too. Yeah, there you go. So that one's not very interesting. We do have query params we can pass in here. We can say sort IMDb score or whatever. The land. Oh, we did that wrong. It should be and sort IMDb score. It changes. By ID, this isn't an IMDb ID. This is actually a one of the MongoDB IDs. So there's one of them. I could put in some gibberish here. It's not going to work. There's another one. Get all by type. I'm saying if I want movies or shows, so I'm going to get all movies if I put in movies. All by name. This is the fuzzy search. You can type in whatever you want here. There's Monty Python. By name, we'll try something else. Now they have Deliverance. There's the film Deliverance. Search shows. This is only shows. I don't know if this account is subscribed to shows or not, but I'll try. It is, yeah. Okay, yeah, all the shows, Monty Python shows. What else did I do? I'll get one of these IMDb IDs and pass it in. Yeah, so it works by that as well. Again, I know that's in capitals. It's maybe I can make a little spelling mistake. Probably 90 Python. Yeah, still works. Add title. I think I have some JSON here already. Yep, there's a new one. And then did I give it an IMDb ID? I did. So let's search by IMDb ID and see is it there. Yep, there you go. Update title by ID. We'll take again that one that we just made. Oh, sorry, that's IMDb. It's not MongoDB. It's an ID. Find new title. It's fine. Delete title. ID. There you go. This is avatars. View all the avatars. So all of them, I had them on S3. You can have a look at them. Creating an avatar. I don't think I should really go through all of these because I've been talking for a long time already. Yeah, I think I'll probably just end it there because this has gone on for quite a while already. That's been my presentation. If I skipped over some stuff too much, then my comments should explain it fairly well anyway. Hopefully that was enough. Thank you very much for watching.